Emergency stop buttons are required near motors. According to NFPA 70E, emergency stop buttons should be located within easy reach of personnel involved in servicing or operating the machinery. An emergency stop button is not considered a controller. A controller is a device that commands or influences the starting, stopping, or speed of a motor. Emergency stop buttons are not used to control the operation of the motor, but rather to stop it immediately in case of an emergency. The push button does not need to be lockable. The purpose of an emergency stop button is to provide an immediate and accessible means of stopping the machinery in case of an emergency. Making it lockable would hinder its intended function. The push button does not need to indicate on OFF. Emergency stop buttons typically do not indicate on OFF status, as they are either pressed or released. They are designed to be intuitive and easy to use even in low light conditions or emergencies. In more detail, consider the implications of each of these points. The requirement for emergency stop buttons near motors is driven by safety considerations. NFPA 70E, which addresses electrical safety in the workplace, emphasizes the importance of having readily accessible means to halt machinery in emergency situations. This is especially critical in locations where personnel are actively involved in operating or maintaining the equipment. The placement of emergency stop buttons should be carefully considered to ensure they are easily reachable from all potential working positions around the motor. This might involve installing multiple emergency stop buttons or strategically positioning a single button to maximize its accessibility. The function of an emergency stop button is distinct from that of a controller. A motor controller is designed to regulate the operation of the motor, including starting, stopping, speed control, and other parameters. Emergency stop buttons, on the other hand, serve a singular purpose to immediately cut off power to the motor in an emergency. This distinction is important because it dictates the design and functionality of each device. Motor controllers typically incorporate features such as overload protection, voltage regulation, and speed adjustment. Emergency stop buttons are designed for simplicity and reliability, with a focus on providing a quick and decisive means of stopping the motor. The non-lockable nature of emergency stop buttons is crucial to their effectiveness. In an emergency, time is of the essence, and any delay in activating the stop mechanism could have serious consequences. A lockable emergency stop button would require a key or combination to unlock, which would significantly slow down the response time. The design of emergency stop buttons prioritizes immediate access, ensuring that anyone in the vicinity can quickly activate the stop mechanism without the need for special tools or knowledge. The absence of an OFF indication on emergency stop buttons is also a deliberate design choice. Emergency stop buttons are intended to be intuitive and easy to use, even in stressful situations. A non-OFF indicator would add complexity to the design and could potentially confuse users. The focus is on providing a clear and unambiguous means of stopping the motor, regardless of the ambient lighting conditions or the user's familiarity with the equipment. Emergency stop buttons typically use a mushroom-shaped button that is brightly colored, usually red, to make it easily identifiable. The button is designed to be easily depressed, even with gloved hands. The emergency stop circuit should be designed to be fail-safe. This means that if there is a break in the wiring or a failure of a component, the motor will stop. The emergency stop circuit should also be designed to prevent accidental restarts. Once the emergency stop button has been pressed, the motor should not be able to be restarted until the emergency stop button has been reset and a start command has been given. In the specific scenario described, the pumping station has 3 pumps in one room and the variable frequency drives, or VFDs, and disconnects in another room. This configuration presents some challenges for emergency stop button placement. The emergency stop buttons near the motors should be connected to the VFD in such a way that pressing any of the emergency stop buttons will immediately stop all 3 motors. This can be accomplished by wiring the emergency stop buttons in series and connecting them to the emergency stop input of the VFD. The VFD should be programmed to stop the motors immediately when the emergency stop input is activated. The disconnect should also be accessible in case it is necessary to isolate the motors from the power supply. The disconnect should be located in a place that is easily accessible and clearly marked. The emergency stop buttons should be tested regularly to ensure that they are functioning properly. The testing should include pressing the emergency stop buttons and verifying that the motors stop immediately. The testing should also include verifying that the motors cannot be restarted until the emergency stop buttons have been reset and a start command has been given. In addition to the emergency stop buttons near the motors, it may also be necessary to install emergency stop buttons in other locations, such as near the VFD and disconnects. The decision of where to install emergency stop buttons should be based on a risk assessment of the pumping station. The risk assessment should consider the potential hazards associated with the equipment and the likelihood that personnel could be exposed to those hazards. The emergency stop buttons should be located in places where they are most likely to be needed in an emergency. It is important to remember that emergency stop buttons are only one part of a comprehensive safety program. A comprehensive safety program should also include training, procedures, and personal protective equipment. Training should be provided to all personnel who operate or maintain the equipment. The training should cover the hazards associated with the equipment, the procedures for operating and maintaining the equipment safely, and the proper use of emergency stop buttons. Procedures should be developed for all tasks that are performed on the equipment. The procedures should be written in a clear and concise manner and should be readily available to all personnel. Personal protective equipment should be provided to all personnel who operate or maintain the equipment. The personal protective equipment should be appropriate for the hazards associated with the equipment. By implementing a comprehensive safety program, it is possible to reduce the risk of accidents and injuries in the pumping station. Consider the implications of improper placement of the emergency stop buttons. If the emergency stop buttons are not located in easily accessible locations, personnel may not be able to reach them in time to prevent an accident. This could result in serious injury or even death. Similarly, if the emergency stop buttons are not functioning properly, personnel may not be able to stop the equipment in an emergency. This could also result in serious injury or death. It is therefore essential to ensure that emergency stop buttons are properly located, installed, and maintained. Regular inspections and testing should be performed to verify that the emergency stop buttons are functioning correctly. Any defects should be corrected immediately. In addition to the requirements of NFPA 70E, there may be other applicable codes and standards that must be followed. These codes and standards may vary depending on the location of the pumping station. It is important to consult with a qualified electrical engineer to ensure that the pumping station complies with all applicable codes and standards. The electrical engineer can also provide guidance on the proper selection, installation, and maintenance of emergency stop buttons. In summary, emergency stop buttons are a critical safety component in a pumping station. They should be located in easily accessible locations designed to be intuitive and easy to use and maintained in good working order. By following these guidelines, it is possible to reduce the risk of accidents and injuries in the pumping station. Let's delve deeper into the technical aspects of emergency stop systems. The emergency stop circuit typically consists of several key components. Firstly, the emergency stop button itself. Secondly, a control relay or safety relay. And thirdly, a means of interrupting the power supply to the motor, such as a contactor or motor starter. The emergency stop button is designed to be a normally closed contact. This means that in the normal state, the contacts are closed and current can flow through the circuit. When the emergency stop button is pressed, the contacts open, interrupting the flow of current. The control relay or safety relay is used to monitor the state of the emergency stop circuit. When the emergency stop button is pressed and the contacts open, the control relay de-energizes. This de-energization triggers the relay to open its contacts, which in turn interrupts the power supply to the motor. The contactor or motor starter is used to switch the power supply to the motor on and off. When the control relay de-energizes, it causes the contactor or motor starter to open its contacts, disconnecting the motor from the power supply. The emergency stop circuit should be designed to be fail-safe. This means that if there is a break in the wiring or a failure of a component, the motor will stop. This can be achieved by using normally closed contacts in the emergency stop circuit and by using a control relay that is designed to energize in the event of a failure. The emergency stop circuit should also be designed to prevent accidental restarts. Once the emergency stop button has been pressed, the motor should not be able to be restarted until the emergency stop button has been reset and the start command has been given. This can be achieved by using a latching relay in the emergency stop circuit. The latching relay will remain energized until it is manually reset. When the latching relay is reset, it will allow the motor to be restarted. The emergency stop system should be tested regularly to ensure that it is functioning properly. Testing should include pressing the emergency stop button and verifying that the motor stops immediately. The testing should also include verifying that the motor cannot be restarted until the emergency stop button has been reset and a start command has been given. The emergency stop system should be designed and installed in accordance with all applicable codes and standards. These codes and standards may vary depending on the location of the facility and the type of equipment being controlled. It is important to consult with a qualified electrical engineer to ensure that the emergency stop system complies with all applicable codes and standards. The selection of emergency stop buttons should be based on several factors. Firstly, the environment in which the button will be used. Secondly, the frequency with which the button will be used. And thirdly, the level of safety required. Emergency stop buttons are available in a variety of styles and sizes. Some emergency stop buttons are designed to be flush mounted, while others are designed to be surface mounted. Some emergency stop buttons are designed to be waterproof, while others are not. The emergency stop button should be selected to meet the specific requirements of the application. The installation of emergency stop button should be performed by a qualified electrician. The electrician should follow all applicable codes and standards when installing the emergency stop buttons. The emergency stop button should be installed in a location that is easily accessible and clearly marked. The emergency stop button should be tested after they are installed to ensure that they are functioning properly. The maintenance of emergency stop buttons should be performed on a regular basis. The maintenance should include inspecting the emergency stop buttons for damage and testing the emergency stop buttons to ensure that they are functioning properly. Any damaged emergency stop buttons should be replaced immediately. The testing of emergency stop buttons should be performed in accordance with the manufacturer's instructions. The testing should include pressing the emergency stop button and verifying that the motor stops immediately. The testing should also include verifying that the motor cannot be restarted until the emergency stop button has been reset and a start command has been given. Let's discuss the integration of emergency stop systems with variable frequency drives. Variable frequency drives offer several advantages for motor control, including energy savings, improved process control, and reduced motor stress. However, it is important to ensure that the emergency stop system is properly integrated with the variable frequency drive to ensure that the motor can be stopped quickly and safely in an emergency. There are several ways to integrate emergency stop systems with variable frequency drives. Firstly, hardwired emergency stop circuit. Secondly, network-based emergency stop system. And thirdly, safety-rated variable frequency drive. A hardwired emergency stop circuit is the most common method of integrating emergency stop systems with variable frequency drives. In this method, the emergency stop button is wired directly to the emergency stop input of the variable frequency drive. When the emergency stop button is pressed, the variable frequency drive immediately shuts down the motor. This method is simple and reliable, but it requires that the emergency stop button be located close to the variable frequency drive. A network-based emergency stop system uses a communication network to transmit the emergency stop signal from the emergency stop button to the variable frequency drive. This method allows the emergency stop button to be located further away from the variable frequency drive. However, it is important to ensure that the communication network is reliable and that the emergency stop signal is transmitted quickly. A safety-rated variable frequency drive is a variable frequency drive that is designed to meet specific safety standards. These variable frequency drives have built-in safety functions such as Safe Torque Off, which can be used to stop the motor quickly and safely in an emergency. Safety-rated variable frequency drives are more expensive than standard variable frequency drives, but they offer a higher level of safety. When selecting a method for integrating the emergency stop system with the variable frequency drive, it is important to consider the specific requirements of the application. Factors to consider include the distance between the emergency stop button and the variable frequency drive, the level of safety required, and the cost of the system. Regardless of the method used, it is important to ensure that the emergency stop system is properly tested and maintained to ensure that it is functioning properly. Let's consider some additional points related to the emergency stop systems. Firstly, risk assessment. Secondly, training. Thirdly, documentation. And fourthly, periodic review. A thorough risk assessment should be conducted to identify all potential hazards associated with the machinery and the need for emergency stop devices. This assessment should consider the likelihood and severity of potential accidents and should guide the placement and type of emergency stop devices used. Comprehensive training should be provided to all personnel who operate or maintain the machinery. This training should cover the location and operation of emergency stop devices, as well as the procedures to follow in the event of an emergency. Clear and concise documentation should be maintained for the emergency stop system. This documentation should include the location of all emergency stop devices, the wiring diagrams for the emergency stop circuits, and the procedures for testing and maintaining the emergency stop system. The emergency stop system should be periodically reviewed to ensure that it is still effective and that it meets the current needs of the facility. This review should include a reassessment of the risks associated with the machinery and an evaluation of the performance of the emergency stop system. It is important to remember that emergency stop systems are only one part of a comprehensive safety program. A comprehensive safety program should also include engineering controls, administrative controls, and personal protective equipment. Engineering controls are physical changes to the workplace that reduce or eliminate hazards. Administrative controls are procedures or policies that reduce the risk of accidents. Personal protective equipment is equipment that protects workers from hazards. By implementing a comprehensive safety program, it is possible to reduce the risk of accidents and injuries in the workplace.